Quick question. What would you use if you were to filter green tea from its leaves into a cup? I asked the same question to my friend Adam, and he was not able to answer. Then I gave him a hint. The answer has the word Eve in it. And he jumped up with excitement and said, Sieve, Sieve, the answer is Sieve. Did you also say the same? Then you are a genius. Pat on your back. Go stand in front of the mirror and give yourself let's keep it super simple. Give yourself a look of pride. Sieve isn't just used to filter out green tea. It is also used in mathematics to filter out prime numbers. Now, we are not discussing about a literal sieve here. Prime numbers are numbers whose only multiples are the number 1 and the number itself. Which means that if you have a bag filled with prime number of body lotions, there are only 2 ways to distribute it equally among people. Either give the whole bag to one person, and let's call it the case of desperation, or give one bottle to one person until you run out of bottles, and let's call it the case of being humble. That's it. There is no other way. For example, let's say you have 8 body lotions. Now you have 4 ways to distribute it equally among people. Give all the 8 bottles to someone who needs it desperately, give 4 bottles to 2 people, give 2 bottles to 4 people, or give 1 bottle to 1 person. Along with the cases of desperation and being humble, we had 2 another distributions here. So 8 is not a prime number. But what about 3 body lotions? You have the case of desperation and the case of being humble. If you can come up with any other case, do not comment below. Make a call to the Guinness Book of World Records, or get in touch with someone from Numberphile or Netflix and propose them a documentary. 3 was never prime. And also give me the credit for suggesting the title and maybe a check. So what's up with Sieve? Let's say we have the first 100 natural numbers in our habitat and we have to filter the prime numbers. Now 1 is not a prime number, so we start our algorithm with the number 2. Now what to do with the number 2? We will visit all the numbers that come after 2, and if the number is divisible by 2, we will allow it to pass through the sieve. Now every even number is divisible by 2, so that means all even numbers pass through the sieve. Passing through the sieve means that you are not important. You are not a prime number. So every even number passes through the sieve except the number 2, which means 2 is the only even prime number. We move on our algorithm with the next number, which is 3, and visit every number after 3 that is currently not sieved. And all the numbers that are divisible by 3 which are still alive, like 9, 15, 21, etc., these will be sieved. And we continue this with all the numbers. And after knocking off numbers, what are we left with? The numbers who were never multiples of any other number. Or to say it completely, the numbers who were never multiples of any other number smaller than them. By the way, can a number be a multiple of a larger number than itself? Again, if you come up with an example, don't comment below. Just get in contact with any of these 3. This algorithm is also known as the Sieve of Eratosthenes, named after the ancient Greek mathematician. Can you guess the name of the mathematician? It's Eratosthenes. Normally, if you were to find if a number is prime or not, you would go through all the numbers smaller than that and check if the target is a multiple of any of them. So for example, to check if the number 29 is prime or not, you would go through all the multiples from 2 all the way to 28 and check if 29 is a multiple of any. Since it's not, it's a prime number. It's an important number. It's an old saying that prime people, or people who will one day hold a legendary status, are sometimes born on 29. To accelerate the process, you don't need to go through all the smaller numbers. Just stop at the square root of the target number. Why? Because well, I never cared for the proof, but for any given number, all the multiples repeat after the square root. Let's see it for 100, let's say. So we have 1 into 100, 2 into 50, 4 into 25, 5 into 20, 10 into 10. Now, did somebody place a mirror here because these multiples are looking like mirror images? Well, it's because they repeat after the square root. And this is true for all the numbers, including prime numbers. So you can save yourself a lot of time checking if a number is prime or not from linear to square root. Well, this was a long discussion on prime numbers. Thanks for watching.